Replace it. All right, so I wanted to start with this warm-up. Guys, we are getting started. We are recording. Okay, so I wanted to start with this warm-up on adding fractions, because some of you forgot how to add fractions. I had that on paired. Get More Math. Sorry, I couldn't think of the name of what we do. I had that on Get More Math briefly, and a lot of people were struggling with it, so I took it off. So when you're adding 3/8 plus 1/4, Caitlin, what would our common denominator be?
8.
8. So we'd have 3/8 plus how many eighths?
3/8.
Good. And 3/8 plus 2/8 is how many eighths?
5/8.
5/8. Good. Okay, so when you're adding fractions, you don't add the denominators together. It's like you're saying you have a pizza, it's in 8 slices, one person ate 3/8 of the pizza, the other person ate 2/8 of the pizza, so altogether they ate 5/8 of the pizza. The bottom number is just telling you what it's cut into, you're not adding the bottom. Okay, Ava, the second one, we'll go with this one. What's the common denominator? 10. 10? So this one would be what? 4/10 plus negative. Good. Now, when we are dealing with signed fractions, we follow the same rules as integers. So we have different signs. So what do we do to those two numbers? Subtract. What do we get? -1. 10. Good. -1. 10. Okay, questions so far? Okay, Allie, next one. What would the common denominator be?
18.
You could use 18. You could also have used something that was 6. 6, yeah. You could use 6. And then how many 6 would this one be? 2. Okay, same signs, adding, keep. So what do you end up with? Negative, yep. Adding, keep. So we want to keep the sign. -7/6. As a mixed number, that's just -1 and 1/6. When you're changing an improper negative fraction to a mixed number, you just ignore the negative sign and change it to an improper fraction just like you would normally do, and then just remember to make it negative. Emily, common denominator for the last one.
I got 63.
Yeah, 63. I'll tell you what, and what Allie did on this one was just multiplied 6 times 3. It always works to multiply the two bottom numbers together to find a common denominator, because then you know each number goes into it. Sometimes there's something lower, there's not in this case. Okay, so how many 63s would this one be?
9.
What's that?
9. You would multiply.
Multiply this by 9, so how many would that be on top then?
18.
18. Good. -18 over 63 plus, what do we have up here?
7.
7. For an answer of how many?
I didn't do the problem, so.
No, different signs. So what do you do when the signs are different? Same signs add and keep. Different signs subtract. So you have to subtract the numbers when the signs are different.
You do 18 minus 7.
Uh-huh. 11. Would it be positive or negative?
Negative.
Negative. Good. -11 over 63. Okay. Any questions about any of that basic adding fraction stuff? Because you will need that for today's lesson. Okay. I actually really liked today's lesson. I wasn't sure about it last year, but I revised it a little bit, and I like the revised version. So we're still on this same standard of applying properties of operations to add and subtract rational numbers. We are adding and subtracting mixed numbers, which is what we did on Friday. But on Friday, we used the number line. Today, we're not going to use the number line. So since a lot of you didn't like writing the number lines anyhow, you should be happier with today's lesson. And the two questions we should be able to answer at the end are, how can I add and subtract signed mixed numbers, and how can I add and subtract signed decimals? Okay, first thing that you need to know is that every mixed number can be rewritten as a sum. So if we have the number 2.5, this means, and a lot of my lines get cut out here, this means 2 plus 1/2. 2 plus 1/2 is 2.5. So we can rewrite it this way. -3 and 1/3 can be written as -3 plus -1/3. Have this line in there. What could 5 and 1/5 be rewritten as? Sammy?
5 plus 1/5.
Good. 5 plus 1/5. And -7 and 5/6 could be rewritten as what? Ava?
-7 plus -5/6.
Good. -7 plus -5/6. This is going to be very useful when we're adding a lot of mixed numbers. Yes?
Can I please have a paper?
Oh, you didn't get one?
Yeah.
Maybe
Honor
I'll-
got one.
You didn't get one either?
I had no Honor got one.
I don't know.
You didn't have one either. Oh my goodness. Somehow, whenever we were switching seats, we got all mixed up. Anybody else not have a paper? There you go. Anybody else? Okay. So I'll give you a second to copy these notes down real quick. Pause this. So on this page, we'll just quickly go over these. Haley, letter A.
-9 plus -5.
Good. Okay, letter B, Jack.
-2 plus -.
Good. Letter C, Andrew.
8 plus 11/12.
Good. Okay, then the next, it says exercise 3, represent each sum as a mixed number. We're just going backwards. We're taking and finding the sum of the two numbers that are represented. Katie, what would the sum of -1 plus -5/12 be?
-1.
Good. Letter B, Connor Hartst. Good. And letter C, Maddie. Good. Okay, so pretty easy up to this point, right? Now, we get into where we're actually going to use this. So when we are solving problems involving signed mixed numbers and decimals, I have a set of kind of rules or procedure to follow. First thing is to change all subtraction to addition, because remember that subtraction is the same as adding the opposite, so it's a lot easier if we change all the subtraction to addition. And we're going to do what we just did, split all mixed numbers into their sums. That's number 2. Number 3 is you're going to use the commutative property of addition. That's the property that tells you that you can move the numbers around and change the order of the numbers and you'll still get the same answer. That's why we change everything to addition, because if it were left as subtraction, subtraction is not commutative. So everything is written as addition. We can move the whole numbers so that they're right next to each other and the fractions together. Then we're going to use the associative property of addition. That's the one that tells us we can group things and we can add them in different orders. So we would be able to add all the whole numbers together. We can add all the fractions or decimals together. And then fifth thing is we just use our integer rules that we learned, because those apply to fractions as well, to solve the problem. So we're going to do some problems and take a look at what this looks like. Some of these problems you might think, well, it's kind of tedious to do it this way, but the way that I normally would do mixed numbers, the way I learned to do it, seems easier at first, but this is much easier to eventually do problems in your head if you do it this way. So just trust me on that, and even though it may seem tedious to do all the steps, it really is a really neat way of thinking about it. Okay, so step 1, change all subtraction to addition. So since this says 5 1/3 minus 1, I'm going to follow step 1 and I'm going to rewrite it as 5 1/3 plus -1. Okay, step 2 tells me to split all mixed numbers into their sums. So for step 2, I'm going to say 5 plus 1/3 plus -1. Step 3 says to use the commutative property of addition to move whole numbers and fractions together. So I'm going to take this -1 and I'm just going to write it right next to the 5. So I'm going to write 5 plus -1 plus 1/3. Step 4 tells me to use the associative property to add the whole numbers and then the fractions. We only have one fraction, but what I'm going to do for step 4, I'll rewrite this, but you could actually do this all in one step. I'm going to put the 5 plus -1 in its own parentheses to show that I'm going to add that together first. That's what associative property usually deals with, parentheses, because we're usually grouping things. And then I'm going to use integer rules for number 5. So I'm also going to use order of operations. I'm looking at what's in the parentheses. 5 plus -1 is 4, and then I have plus 1/3. And 4 plus 1/3 is just 4 and 1/3. That was a lot of work for a problem that you probably could have just looked at and said 5 1/3 minus 1 is 4 1/3. That problem you could probably easily have done in your head, but it's also a good problem to follow step by step just to see how this works. Yes?
What was the point of doing all of that work just to do?
The point is when they get harder, this will be extremely helpful.
That's what
The
you
first
guys
time I
have.
did the problems like this, I was like, oh, this is really tedious and long. I don't think I like this. After I did about 5 problems this way, I caught on to it really quickly and I was like, this is great. Why didn't I learn this the first time I learned how to add mixed numbers? It really, really works well when you're dealing with signed numbers. It's much less confusing. The students last year did much better doing it this way than my students in past years doing it the old way, so you just have to trust me on this. It really is easier. All right, let's go through another example. So first, we don't have to do step 1 because it's already addition. There's no subtraction. So we can skip step 1 on this. Step 2, we're going to rewrite it as the sums. So we have -2 plus -1/4 plus 5 plus 3/4. Step 3, I'm going to use the commutative property. So I'm going to put my 2 whole numbers together, and I'm going to put my 2 fractions together. Now, step 4, I'm going to use a different color. If you want to completely rewrite it, you can. I'm just going to combine that with this step. And I'm just going to show, I honestly, when I'm doing these, don't always write parentheses. Sometimes I just go ahead and add the whole numbers, add the parentheses, but I want you to see and understand each property, because sometimes you'll see problems. I've seen PSSA examples where it wants you to tell what all the steps were and what properties they used. So it's important that you're familiar with this. Okay, then step 5, I'm going to go ahead and add my whole numbers together. -2 plus 5 is 3. -1/4 plus 3/4 is 2/4. So I have 3 plus 2/4, which is 3. And I'm going to go ahead and reduce that fraction to 3.5. Okay, looking at number 3. Number 3 has a decimal, so I'm going to talk through this one with you too. You do it the same way. So first we're going to change it to addition. -7.3 plus -6.4. I'm going to rewrite it just like I did with the mixed numbers, but I'm going to separate the whole numbers from the decimals. So I have -7 plus -0.3 plus -6 plus -0.4. Move my numbers around. -7 plus -6 plus -0.3 plus -0.4. I'm going to go ahead and add step 4 here. I'm going to add these 2 together and then these 2 together. So I have -13 plus -0.7, which is -13.7. That's another example where it would have been easier just to line up your decimals vertically. But I do want you to go through this long process so you start to get it and you get really quick at doing it. Eventually, you'll use this process to just do these problems in your head if you get enough practice with it.
Well,
Okay, number 4. Tessa, what's my first step?
Negative 3/4 plus negative 1 and
Careful not, it's not going to be negative. If we have minus a negative, we're adding the opposite, so we're adding the opposite. So it's just plus. Step 2, Ellie.
negative 3/4 plus 1 plus 1.
Good. Step 3, Carly.
1 plus 3/4
Careful, it's in front of the 3/4.
negative.
Yeah, make sure you keep the signs with their numbers.
Plus
Step 4, Connor Robinson.
you add the fractions,
Okay, so I'm going to show,
or the fractions.
yeah, show that I'm going to add the fractions. That was step 4. Okay. Step 5, Chris.
Negative 3.
This one you have to get a common denominator, so 1/2 would be how many fourths?
2/4
Uh-huh,
minus 3/4 plus negative 3/4
uh-huh.
equals 1/4, negative 1/4.
Negative 1/4, so we have 1, don't forget to bring down your 1, plus negative 1/4, and what's that?
Plus 1 equals 3/4.
Equals 3/4, good. Okay, any questions about this? Okay, I'm going to give you a few minutes to try 5, 6, 7, and 8 on the next slide. I want you to go through all 5 steps. You can number the steps. You don't have to write out what the properties are, just number the steps like I did. You can combine 3 and 4, and then we'll go over
They
these
should have
in
given us
a
at
minute.
least more work.
Yeah. You don't have to.
Okay, switch it to addition. So what's that going to look like, Charlie?
4 into the plus negative 7 and 7.
Good. Okay, step 2, Caden.
1, 2, okay, so that's 5, so it would be 4 plus 2/5
Mm-hmm.
plus negative 7 plus negative 7/10.
Good. Step 3, Ava.
Number 6.
Uh-huh.
0. 4 plus 2/5.
No?
Oh, 4 plus negative 7.
Good.
Plus 2/5 plus negative 7. Sorry, I was doing that.
Okay, step 4, Allie.
I'm going to 4 plus negative 7. And then 2 plus, 2 plus 7, negative 7.
Good. Emily, step 5, go ahead and add what's in the parentheses for us.
So you get negative 3
Uh-huh.
and negative 3/10.
Okay.
And for the answer, I got negative 2 and 7/10.
Okay, I agree with you up to the negative 3 plus negative 3/10, but now we have same signs. What do we do when we have the same signs? Add. So you are, let's look at what this looks like on the number line. You're going to negative 3. You're adding a negative 3/10, which means you're going 3/10 more to the left. So it's just -3 3/10. It doesn't go backwards like it did on the other one. This is where looking at it on the number line is really helpful because it's easy to get this part mixed up. Okay, go ahead and take a little more time to work on 7 and 8. For number 8, I would either change both to decimals or change both to fractions. I like working with fractions better, so that would be my pick. But if you prefer to change it to a decimal, you may. Plus 10 plus 0.1. Okay, so that was step 2. We got to skip step 1 on this one. Step 3, we move the whole numbers next to each other and the decimals next to each other. Step 4, we group them. So -6 plus 10 is 4. -2 plus 0.1 is -0.1. And again, if we use the number line to imagine this, we are at 4. We're subtracting 1/10, so we end up at 3 9/10. So the answer to that one is 3.9, or you could have written 3 9/10 as a fraction, if you so desire. Okay, number 8. Let's see, I'll have you guys give me the steps on number 8, I think. Haley, step 1.
Step 1, you have to change it, well, you don't really have to change it because
Right, so there is no step 1. Great answer. Now step 2. You could do step 2.
-3 plus, I changed it to a fraction.
Good, good.
Plus -4/10 plus 2 plus 1/5.
Okay, very good. Step 3, Jack.
All right, -3 plus 2 plus 1/5 plus 4 and
-4/10, good. And you switched the order of the 1/5 to the -4/10, which is perfectly fine. You can do that. Step 4, Andrew.
I didn't get
But what is step 4? What do we do?
put it
So what do we put in parentheses?
-3 and then next to 2
Mm-hmm.
and 1/5 and 4.
Good. Okay, step 4, Katie.
You put the parentheses around.
Already, oh, sorry, I'm sorry. We did step 4. Step 5, I meant to say.
Well, negative,
Okay?
-1
Uh-huh.
plus, -1/5.
Good. -1/5. You would have gotten -2/10, which reduces to -1/5. Same signs, add and keep. Connor Harps, what's our final answer? Good. -1 and 1/5.
Is that equal to -1.2?
Yes. If you have -1.2, if you have -1 and 2/10, you just didn't reduce. Okay. Questions?
It's still right?
Yes. Yeah, I wouldn't mark it wrong. I might take off a little if I asked you to show everything in lowest terms. Okay, last 2 problems we're going to go through fairly quickly. This one, you're going to follow the same steps. You just have 3 numbers, so you have more things to keep track of. So, Maddie, what's step 1?
-3 plus -5, 2/5
-2/5, good.
plus 3
Whoops, actually we skipped a step. Go ahead, keep going.
plus 1/4
Mm-hmm.
plus -3/5.
Good. Okay, so Maddie actually combined steps 1 and 2 all in one there. So instead of rewriting this just as addition, she put the -2 plus -2/5. So she split it as well as wrote it as addition the first time through. You might want to do a pure step 1 where you write -2 2/5 plus 3 1/4 plus negative 3/5. Okay, Tessa, step 3.
It would be -2 plus 3 plus -2/5 plus 1/4 and then plus -3.
Okay, now, I am going to take step 3 a step further. I'm going to show you something else you can do. So when I'm looking at these fractions, I'm saying, ooh, these both have a 5 on the bottom. I can add those together without even getting a common denominator. So I'm going to leave this -2 plus 3 here. And then I'm going to actually change this grouping. I'm going to put the -2/5 plus -3/5 right next to one another, just because it's easy and I can add those together. So I'm going to do that. I'm going to go ahead and add my -2 plus 3 as 1. And then if I add -2/5 plus -3/5, Ellie, what is that? Yeah, it's -5/5, which would reduce to -1. So you have -5/5 plus 1/4. Well, -5/5 is actually -1, right? So now I have 1 plus -1 plus 1/4. If I add 1 and -1 together, Carly, what do I get? 1 plus -1? 0. Yeah, so I'm just left with 1/4. So as you're doing these, you're not always going to write out every step of this. You might think to yourself, oh, wait a second. I could add these together. You might not even rewrite them. You might just add them together and say, ooh, that's -5/5. That's -1. This is 1. So that cancels out. You might start to skip some steps. I don't advise skipping steps right now because I think it would be detrimental, and I think that you would end up making silly mistakes because you don't have a lot of experience doing this. But for me, I'm just going to automatically from the start adding these whole numbers and adding the fractions that have the same signs together in my head to make it easier for me to do this in my head. Yes? Wait, just one more. Then you can go. Okay. Last problem is just what this looks like in a word problem. We're not going to have any word problems to do for homework. So, Mr. Mitchell lost 10 pounds over the summer by jogging each week. By winter, he had gained 5 1/8 pounds. Represent this situation with an expression involving signed numbers. What is the overall change in Mr. Mitchell's weight? So let's start by writing an equation to represent this situation. Connor Robinson, what do you think we could write as an equation?
-10 plus 5 1/8.
Very good. He lost 10 pounds, so that's a negative number. And then he gained, which is positive, 5 1/8. So going through our process, it's already written as addition. Chris, what would be my next step?
-10 plus 5 plus 8.
Good. And then the whole numbers are already written next to each other, so we can just easily group them. Bryce, what is -10 plus 5?
-5.
Good, so we have -5 plus 1/8. Bella, are we going to add those numbers together or subtract them? No, it says addition, but when we're adding sign numbers, remember we have same signs add and keep, different signs subtract. Keep the sign of the larger number and then you'll be exact. So we have different signs. The 5 is negative, the 1/8 is positive. So what's 5 minus 1/8? 4 7/8. Good. And we want to keep the sign of the larger number. So is that going to be positive or negative?
Negative.
Negative 4 7/8. And we can visualize that on a number line. If we started at -5 and we moved 1/8 to the right, we would be at -4 7/8. Okay. go ahead and do the 2 problems on the exit ticket. That's your first thing. We're not gonna do one of the activities we were gonna do today. We'll save it for tomorrow. And I'm also gonna cut down, I think I'm just gonna have you do all of the odd numbered problems on the worksheet. So you'll only have 6 problems to do on the worksheet, and then you'll have 6 problems to do on Get More Math. So 2 problems on the exit ticket, 6 problems on here. This is actually a little easier than the ones you've been doing. 6 on Get More Math. Yes.
How do we do it like the exit ticket, like the other?
I just want you to show it to me whenever you're done. We'll make sure you have the right answer. Yes. Okay, wait, hang on, let me click this off.